Is screen visible?
Yes, sir.
Yes, sir.
Yes, sir.
So good morning to all of you.
Good morning,
Good
sir.
morning, sir.
Good morning, sir.
So today we will talk about the one of the paper of MSc Statistics. The title of the or the code of the paper is TS04 TSTA21 oblique TS04 CAST21. The name of the paper is Computer Oriented Statistical Method. Okay. In short, we call them as a COSM. In COSM, we will see the two part. One is of generation of random variables from discrete as well as continuous distribution. So this is the one part. So we will try to first generate the random numbers from pseudo random numbers generator we will use. Then we will generate a random numbers from a uniform distributions. Then we can generate a random number from Bernoulli distribution, binomial, geometric distributions. Okay, so these are the Poisson distributions. So these are nothing but the random number generation from a discrete distribution. We will see the some other method of a generation of a random variables from a continuous distribution. One of the method is a inversion method. So based on the inversion methods, we can try to generate a random numbers from a exponential distribution. So then there are also some other methods are also there. So mainly we will use the methods. Another is the acceptance rejection methods. So that we will see that how to generate if the CDF is not able to invertible, then how to generate a random number from a such a distribution. So we will use the acceptance rejection methods. Then we will see the some the variance reduction techniques, variance importance sampling techniques. Likewise, there are various things are there that we will see in the generation of random variables part. Now, in the second part of that, we will see the multivariate techniques. In multivariate techniques, we will see the principal component analysis. We will see the factor analysis, then cluster analysis, discriminant analysis, canonical correlation analysis, Fox proportion, regression model. So this six techniques we will see in the multivariate analysis. And here one more technique is that we will also see the concept of a resampling. So we will see the bootstrapping method. So that will entirely cover in the COSM part. Okay. So let us begin with the generation of a random numbers. We know that many numerical problems in science, engineering, finance, and statistics are solved through Monte Carlo methods. Now, Monte Carlo names came from the gambling because there is a casino whose name is a Monte Carlo, and it is saying that the most of the statistical techniques is derived, or the concept of the statistical techniques usually came from the gambling. So where we use the Monte Carlo simulation techniques. So there are so many areas like science, engineering, finance, and statistics where there are so many complex problems are there, and the availability of the data is also not available. At that time, we will perform the Monte Carlo methods. And the first use of the Monte Carlo technique has been used in the you can say that this the one of the science lab associated with the atoms. So one of the scientists has used the concept of the Monte Carlo method first, and then it has widely used in the various disciplines. So Monte Carlo methods is nothing but it is an random experiment on computers. So you wish to make all kind of a simulation study, all kind of the hypothetical situation without doing any experiment. You wish to perform in a computer. So Monte Carlo methods are widely used. So one of the aim of random experiment, you can say that the heart of Monte Carlo methods, Monte Carlo method. What is the heart of Monte Carlo method? As I say that we wish to do the random experiment in a computer. That means the random number, because experiment is associated with the randomness, so we require the random numbers. So we say that the random numbers are the heart of Monte Carlo method. And to generate a random numbers, we require the sum generator. So we call them as a random number generator. And random number generator is a kind of a procedure which can produce the sequence of random numbers. Let us say u1, u2. Likewise, it will generate an infinite number of random numbers which are IID, that is identically independently distributed with some f distribution or some distribution function. That means f is nothing but the it is a CDF of distribution. Okay, so what is the role of random number generators? Random number generator will give the series or the stream of the sequence of the IID random numbers. IID means identically, independently distributed, having or this the stream of random numbers generated from the some distributional function f. So when I'm saying that the distribution function, it means that it is associated with the some probability low. Some probability low. If we say that this u1, u2 up to okay, the stream of this sequence of random numbers, if they are generated over the interval 0 1. That means f is nothing but it is a standard uniform distribution. Then we say that u1 u2 up to u1 u2 u3 are nothing but they are the uniform random numbers. So it is a sequence of uniform random numbers. Is that clear up to here, everyone?
Yes, sir.
So as I say that Monte Carlo methods are very important. It has application in the various fields. You can say that it has the application in the science, engineering, finance, statistics, mathematics, everywhere. And whenever there is a very complex situation, you cannot study it physically. So you always try to study that all computational situation or all the complex situation in a computer via Monte Carlo methods. And in Monte Carlo methods, you require the concept of a random experiment. And when you go for the random experiment, you require the random numbers. So there are random numbers tables are there. So how that tables are generated, so that we will see. So whatever the random numbers, a mechanism is useful to generate a set of random numbers, so they are said to be a random number generators. So there are several random number generators are there which can be able to generate a random numbers. But again, the comparison is based on the some properties of a random number generators. So that we will come later. Most of computer language already contain inbuilt random number generator. For example, if you go for the uniform, sorry, in R language, so you can see that R unif. Okay, and if you give the size of a random numbers, let us say 10, then it will generate a uniform random numbers, standard uniform random numbers of size 10 in a fraction of time. So there are so many random number generators are there inbuilt with the most of computer language. One of the example I have given the R. But which mechanism is there to generate a random number? Here you make the some kind of a changes, you can generate the random number from a uniform. Similarly, from the exponential distribution, from a Poisson distribution, binomial, Bernoulli. But how the basic random numbers are generated? What are the different methods are associated with that? So when you say that the inbuilt random numbers are there, so usually the user has to provide the seed. Seed means it is the initial value. Once the user provide the initial value, the random number generator will give the series of random numbers. Okay, and they are IID. IID means if you are trying to verify it, you are not in that position to say that they are distinguishable. Okay, that means they are satisfying the certain properties like randomness, and second one is that it has the certain distribution. So these are the statistical properties. Who is the pioneer person who has given the concept of the random numbers? That is Perry L. Usher. Who is the person who has given the concept of a random number generator? And then there are lots of research is taking place after this. So he has given this some algorithm. What he suggested, he has given the algorithm based on the, so he say that random number generated is identified by the some tuple. Tuple means it is a set of a parameters or the set of the variables which you require together. S, then F, mu, U, and small g. So he has given this five different notation and the or the five different variables, or you can say that the functions or the nomenclatures which is useful for the algorithm which he has given. So what is S? S is nothing but it is a set of states. Set of states. Sorry. Set of states. And that is nothing but it is a finite. So whatever the set you have given, it is a finite state space which takes value, let us say 0, 1 up to s minus 1. What is f? F is nothing but it is a function which is defined from s to s. That means the function which is taking the argument from s and the range is also the s. The result of the function or the value of the function is also belong to s. Mu is nothing but it is a probability distribution on s. It is a probability distribution of s on s, not of. It is a on s. What is a mu? Mu is nothing but it is a output. It is a output space. For example, if you talk about the uniform random numbers, then u is belong to 0, 1. That means whatever the outputs you are getting, that is getting in the range 0 to 1. And g is a function of, it is some function of s to u. So you apply the function on s, whatever the results you are getting, that is nothing but the final output, and it is a sequence of a random number. So five things you should know while generation of a random number. What is the state space or the finite set of states? What is a function? That is the functional relation between the state space to state space. That means the result of the again the functional value is again the same state space. What is the probability distribution? You have defined on S. U is the output and G is the some functional. It is a function of S whose output or whose result is in the U. So he has given the steps of algorithm. Few steps he has given, and these steps are nothing but it is giving the, if you perform these steps, it is giving the generic random number generators. Okay, so what if you follow these steps, then it will create the random number generate. It will give the series of the random numbers, and therefore it is known as generator. And but it is giving the generic result, similar to generic drug. So the first step of the algorithm, we say that you should provide the initialize. So first you have to initialize the generator. So how to initialize? So we say that first give seed. As I said that as a users you have to supply the initial value. So let us say give seed S0 from the distribution. डिस्ट्रीब्यूशन को हमने क्या डिफाइन किया है, म्यू ऑन एस. तो गिव और यू कैन से दैट ड्रॉ a seed or the draw this seed as 0 from the distribution mu. So where distribution mu is given, the distribution mu is given on a sample space S or the state space S, and assign t equal to 1. That means you have given the t is a sequence, and because you have assigned the S0 initial set, so say it is a t equal to 1. So first you have to initialize the generator. What is the second step? He said transition. First is initialization, second one is transition. So what is the transition? He said that set st. So it is nothing but the value of the s, or the value of the, or the position of the state space at time t is nothing but some function of st minus 1. So set initially, when you give the set t equal to 1, what happens? 1 minus 1 is 0, and initial seed you have assigned. So once your initial seed is given, it is the f of s0, and again I say that the function f is from s to s, so result is again also belong to the s. So s can takes the particular st takes any one of the value in the set s. So that is called the transition. The third step is now you have to get the output. The output is a nothing but u. So it means that you have to define another function g, which is a taking a value from the set S, and the result will be u. So it is saying that output set ut. We say u as output. So set output at time t0 t. It is nothing but it is a function g of st. So whatever the results you get in the step 2, define the function or that supply that value to the function g. Whatever the results you are getting, it is said to be ut, and that is nothing but output. And you have to repeat the same procedure. That is, after initialization is done only once, then you have to repeat the procedure between the 2 to 3. So what is the step for? Repeat, or you can say that repeat the procedure. Okay, so you have to set now t equal to t plus 1. So now you have to make a 1 increment in the t and repeat step 2. So now what is the procedure? Now you get the, when the you take the t equal to 1, what happen? You will get the s1 minus 1, that is s0. So you have initialized the s0. So now you will get the s1. After supplying the s1, you will get the u1. So that means you have generated first random number. Now you are setting t equal to t plus 1. So now if you are substituting the t plus 1 into this step 2, it becomes the s 2, that is 2
2.
minus 1, it is a 1, so s1. So if you apply the function of f s1 here, t equal to t plus 1, so it becomes the s2, and you have here you have to give that value of s2 into the function g, you will get the u2. So likewise you can generate the series of numbers. So this is the procedures is given by Pierre L. Usher by generation of a random numbers. The same procedure we will use, only the functional form is changed of f and g. Rest of the thing remain the same. So this is the general procedure he has suggested, and many authors has used as the base procedure. So that is why his contribution is considered to be one of the original contribution in the generation of a generic random number. Any questions up to this? Anyone?
No, sir.
Okay. Later on, we will see the different methods of generation of a random numbers. One of the methods we say that it is a linear congruential generators and multiple congruential generators. And then we can also uh, use the mix of both. That means linear as well as the multiple. So it is also said to be a mixed congruential method. Okay. What are the elements of S that we will see? We'll see the basic methods which can help you to understand how the procedure take place. So here, as I say that S is a finite. So the algorithm produce a sequence of U1, U2, U3 up to you can generate a infinite number of random numbers. They are said to be a pseudo random numbers. Pseudo, it is a together pseudo random number. So what is the meaning of pseudo? Anyone?
False.
Eh?
Proxy. Proxy
False.
false.
Proxy of a false.
Proxy, false, or sometimes you say that ki not origin. Okay.
Yes.
Or you can say that ki artificial, something like that. So these are the proxy random numbers. This is not the original random number, but these pseudo random numbers should be generated in a such a way that it look like as a original sequence of random numbers. Okay, so whatever the algorithm is given by the PSL user is nothing but it is generating the pseudo random numbers. It can start with the initial seed. तो you have to supply, जैसे आप प्लांट लगाने के लिए बनाने के लिए पहले क्या करते हैं, पेड़ के लिए यू रिक्वायर द सीड, उसमें से फिर छोटा सा प्लांट आएगा एंड देन बड़ा ट्री बनेगा. तो इनिशियलाइज दी, तो यू हैव टू सप्लाई दी सीड and then the sequence of states. So once you give the seed s0, then you will following the sequence of the states s0, s1, likewise. Okay, and this is the finite set,
Yes, sir.
and they are said to be, this sequence of set is nothing but it is a random number. Suppose आपको दिया है कि if the s is taking the value, let us say 0, 1, 2 up to 9. So how many elements are there? 0 to 9. You can take any one, you can draw any one as a random seed. ठीक है, और उसके बेस पे आपको क्या मिलेगा, यहाँ पे random seed लिया s t, पहला आपने t equal to 1 and whatever the initially you have given as 0, you supply this function, you will get the another value of s, but that value is also lies between 0 to 9. So you can generate a sequence of random numbers. Suppose first you may get selected 1, and then after it is giving 0, then it may be giving 9, then it may be given 7, 6. So we don't know. This is generating the sequence of random numbers. Okay. But again, the thing is that whether the generation of random number is with replacement or without replacement. That is the another story. So these are nothing but whatever the element of S, you say they are nothing but actually a random numbers, because you are generating as a output whatever the output or whatever the after applying the function f, whatever the results you are getting, it is again in the s. So whatever the numbers you are there, it is nothing but the random numbers. We call them as the stats. S in the 0th position, this is the first state, second state, third state, likewise. So these are said to be stats जो आप stochastic process में पढ़े होंगे 0 to 1. ठीक है, वो you are in the first state. Now what is the probability that you will go to the second state? If you are in the second state, what is the probability that you will go to the first state? So these are nothing but the state. They are said to be discrete state space. आपने ऐसा कुछ पढ़ा होगा वहां पे.
Yes, sir.
Now this process is repeat till all the states may cover. Okay, so ऐसा हो सकता है कि आपने 0 1 2 अप टू 9 तक पहुंचे, वापिस आपका सीरीज स्टार्ट हो जाए 0 1 2 9. Okay, we don't know, but that means whatever the patterns you have, that pattern is going to repeat. So after what time the pattern is repeating, जरूरी नहीं है कि ये 019 ऐसे ही रिपीट हो. It may be of any patterns of set you have generated, but after certain time the same pattern is repeated. तो जो वो टाइम है, कौन से टाइम के बाद पैटर्न चेंज हो रहा है, द स्मॉलेस्ट टाइम पीरियड or the smallest number of, not time period, smallest number of steps taken before entering to previously visited state. सपोज आपका 9 है, ये वाला सीक्वेंस है 0 1 5 7. So after how many steps the same sequence is repeating? So whenever the sequence is started repeating, so that number of steps is said to be a period length. So number of steps, that means it is a length. And after what time it is repeating, so at what period it is repeating. Okay, तो मतलब कि 5 नंबर जन पीरियड लेंथ 5 दिया, इसका मतलब फर्स्ट 5 के बाद 6 whatever random numbers you are getting, that is nothing but the first. So that means what is the length or what is the period length? It is a 5. Getting my point? So it is a smaller number of steps taken before entering into the previously visited state. मतलब जो आपकी पुराना पहला नंबर जो आया अगर रिपीट हो रहा है 1 9 5 7 8. Now again after this again it is repeating 1 9 5 7 8. So how many, after how many state how many steps the things is repeat? So it
6.
is 1, 2, 3, 4, 5. So that means the period length is 5. So now there is a problem. There is a problem. If you identify that after certain time the same system is repeating, for example in stock market, if you identify that after the 10 days now the share value is start increasing, then what happen? Everybody becomes a billionaire, because you know that now the share price is going to increase. Okay, though the random number generators are there, if you look at the theoretically, so they are not actually random. But when when you try to look at the practical numbers, you will realize that no two numbers are identical, because the period length is very large. So if you take the small period length, then that random numbers cannot be a independent. But if the period length is very large, then user could not able to identify whether these random numbers are, or whatever the numbers are generated are random or not. Okay, and therefore the focus is always in the period length. Suppose if you wish to generate the capital N random numbers, then it is saying that the period length should be 10 into n square. Okay, and in usual setup the period length is always 10 raised to 50. So you can see that what is the 10 raised to 50? It is a very big number, because Monte Carlo methods are generating billions of random numbers whenever you are applying the simulation. Okay, chemical reactions are going on. You can talk about the flights. Okay, at what time the which flights are at which positions. So all the data when they are talking about, they do lots of simulations and they are generating the billions of the data. Okay, so general setup, it is saying that if you wish to generate the capital N random numbers, what should be the period length? It should be 10 into n square. And in general setup, the period length should be 10 raised to 50. But this also works well. So there are several random number generators are there. Now which generator is better? Now the question is, which generator I should select? We will come to know that what are the different methods. That will come to the later on. But now the question is that if I have a several generators are there, which method should I adopt? So of course you have to look at the properties of random number generator. So there are some important properties are there. Several research have been taken place on in this regards, and based on the recommendation there are 8 various properties they are looking to identify the best generators. So the thing is that properties of random number generator, RNG. Okay, so first property is that it should pass some statistical test. So it's a first property is that pass statistical test. So why it should pass some statistical test? Because ultimate goal of the generator is that it should produce a stream of uniform random numbers that is indistinguishable from a genuine uniform random number. Okay, so whatever the generators you are using, it should produce the series of uniform random numbers which are genuinely indistinguishable with uniform random numbers which are IID. So how will you identify whether your data are really random or not? So it should pass the certain statistical test. So that we will see the in later what are the statistical tests. One we know that is the runs test for independent, and second whether the data is generated from a specific distribution or not. So we can use the KS test, but KS test is for test for identifying whether the data is generated from a specific distribution or not. So to identify the whatever the sequence of random numbers are generated, they are identical. We will use the run test. There are also some other tests are there that we will discuss later. Now, second property is that it has some theoretical support. See, we are using the when we have started the concept of probability theory, we say that let us conduct a random experiment. So to conduct this random experiment, we said let us flip a coin. A coin has the two outcomes, either head and tails. It should be equally likely. And then we have started performing the random experiment. If the head appears, the certain value will be selected. If the tail appears, then the certain value will be selected. In this way, we can generate a random numbers. So, what is the law associated with that? It has associated the Bernoulli law. So, whenever you are giving any random number generator, it should have a some theoretical support. It has certain mathematical principles. It has a some mathematical principles. So common example is that you are generate the linear congruential method. Mixed congruential methods. Okay. That is multiple congruential methods. And if linear and multiple both, so we call them as a mixed congruential methods. Okay, so of course there are some mathematical properties are that given a value of the seed, you can use the some principle of a linear as well as the multiplication concept, and then you can obtain the random number stack. So these are said to be a generator. Linear congruential method is a generator. Multiple congruential method is also a generator. If you are used the mixed congruential method, it is also a generator. There is a multiple recursive generators. So there are various techniques are there. So that we will see one by one. Now, so first property we have seen that it should pass some statistical test. Second is that it has some theoretical support. And now third will be it should be reproducible. It should be reproducible. So reproducible means, as I say that the stream of random numbers u1, u2, u3 is reproducible without having to store the complete stream in the memory. I don't want to store this all the one set of random numbers which I have generated into the memory and then try to call these random numbers from that memory. No. I wish a generator which should reproduce this sequence without, or you can say, the little use of the memory. You don't want to store entire stream. So the generator should be in a such a way that after the certain time it should help you to reproduce. So that is based on the theoretical support. So generator should be such that it should be a reproducible. And why it is important? It is important because we wish to go for the testing and the variance reduction techniques later on. Okay, when you talk about the estimation part and the testing part, so there are various techniques are there, and it is essential that it should be reproducible. Whatever the data are, or the random numbers are there. Physical generation methods cannot be repeated unless entire screen is recorded. तो फिजिकली आपको कोई भी, जैसे कभी रैंडम नंबर टेबल्स में से आपको वही टेबल्स वापस लिखना है तो वो प्रिंटेड है तो आप लिख सकते हैं. Okay, you cannot remember all the points, but if you have some algorithms you have developed, it is repeating the same sequence of random numbers as and when required without using the, or with using the little memory, not the storing entire things. Now fourth property is it should be fast and efficient. Whatever the random number generator is there are so many, but we are looking that it should be fast and efficient. Okay. 5. So when I am saying that fast and efficient means it requires the lesser memory size. तो आपका रैंडम नंबर जनरेटर आप यूज कर रहे हैं लेकिन बोलेंगे उसके लिए ये सिस्टम चाहिए, वो सिस्टम चाहिए, इतनी मेमोरी चाहिए, तो वो रैंडम नंबर जनरेटर कोई काम का नहीं है. We should have the random number generator which can access the or generate the data very fastly and efficiently without any errors, or you can say that with minimum errors, and use the little memory. Another property is that fifth property is a large period. So whatever the random number generator you are using, it should have a large period. So as I say that the period, ideally the period is usually large value is a 10 raised to 50. But if you wish to generate a random numbers of size capital N, then the period of the random number generator is a 10 into n square. 6. Multiple stream. In many times what happens, you wish to generate the parallel sequence of random numbers. Okay, you wish to generate a series of random numbers but the parallelly. So your generator should be in a such a way that it can allow to generate the random numbers parallelly, or you can say that you can generate multiple random numbers at a time. So you can say that it has a multiple independent streams. Independent streams. Streams nothing but u1, u2, you are generating, so they are said to be streams. It will allow you to generate multiple independent streams. So that should be the property. 7. It should be cheap and easy. Whatever the generators you are using, it should be cheap. That means it requires the minimum support systems, and it is easy to install. It is easy to implement and easy to run. For example, if you are, as I say, that you are using the R unif, okay, in a R language, and if you give the 10,000, in a fraction of time, it will generate the 10,000 random numbers from a uniform distribution 0, 1. And it is very cheap. It does not require the high amount of the memory, etc. 8. Whatever the random numbers generator is with you, it should not produce 0 and 1. Why? If it produces the 0, what happen? 1 by 0. Result is mathematically not trackable. And if you are using the 1, somewhere it is a become the complex. So the numerical calculation become the complex when they are at the extreme point 0 and 1. So your random number generator should always generate a random number from 0 to 1. Okay, it is not adding the 0 as well as 1, so it should not be bracket like square. It should be always this way, open bracket. That means 0 and 1 are excluded. So there are 8 properties we have seen. What is the first property? It should pass some statistical test. Second, it has a theoretical support. That means some mathematical calculation is associated with that. Formulas we can use, some probability laws we can use. Third is that
It's reproducible.
it should be reproducible. Okay, it does not require to store the all the sequence of random variables. Then it should be fast and efficient. Quickly it should access the data with little memory is required. It should have a large period. Then it can help you to generate the independent stream parallelly. That is how it is said to be multiple stream. It is a cheap and easy, and it should not produce 0 and 1. So if you have any generator with you, and if you see that this generator satisfy this 8 property, these are the maximum properties. There are generator cannot all generator satisfy the all the properties together. So you always try to see that a generator which satisfy the maximum properties are considered to be a good generator. So any questions up to this, anyone?
सर थर्ड प्रॉपर्टी एक्सप्लेन कर देंगे सर वापस. It should be reproducible. Sir,
Reproducible means third, na? Reproducible.
Yes, sir.
Reproducible means the stream of random numbers. आपने stream किसको कहा? U1, U2, U3, likewise
Yes.
वो चलता रहेगा. Is reproducible without having to store the complete stream in the memory. तो आपकी जो भी एक बार सीक्वेंस आपने पहली बार जनरेट किया, ठीक है,
Okay.
अब हमने आपको क्या बताया कि बिकॉज द पीरियड के हिसाब से आपको सीक्वेंस वापस रिपीट होगी, इसलिए यूजुअली हम पीरियड कितना लेते हैं, लार्ज लेते हैं, सो दैट यूजर्स कैन नॉट आइडेंटिफाई इजीली दैट
Yes.
दिस सीक्वेंस इज रिपीटेड. वो
Yes.
सेट किसको पता रहेगा? जिसने बनाया उसको, कि भाई ये सीड आपने दिया, ठीक है, और मतलब कि ये पीरियड दिया, तो इसके बाद क्या होगा, आपका रैंडम नंबर रिपीट होगा. If you remember, in our language, we sometimes use the command set dot seed.
Yes, sir.
यहाँ पे sometimes some
Values
number they
देता
are
है.
taking a 197. तो इसका एडवांटेज क्या है कि एक बार ये सेट सीड फिक्स कर दिया तो क्या हो गया कि एक बार जो रैंडम नंबर मैंने जनरेट किया, ठीक है, फिर मैं दूसरी बार करूंगा ना तो सेम ही आएगा. इट विल नॉट गिव द अनदर. तो दैट इज हाउ दी सेट सीड. जब भी हम प्रोग्रामिंग करते हैं तो क्या कहते हैं कि भाई आपका प्रोग्रामिंग सही है कि नहीं, कैसे पता चलेगा? तो मैं यहाँ सेट सीड कर दूंगा. अब मैं रन किया प्रोग्राम और मेरा जो आउटपुट आया वही प्रोग्राम मैंने आपको दिया, तो आपका आउटपुट भी सेम आएगा. इफ आई हैव नॉट
Okay.
सेट दिस पर्टिकुलर सीड, your output and my outputs are different.
Differ. Yes.
Okay, it may not be
Yeah.
the same. Okay, तो reproducible means मुझे इसको स्टोर किए बिना सारी की सारी, जैसे हमने रैंडम नंबर टेबल होते हैं तो आप प्रिंट लेके रखते हो ना,
Yes, sir.
फिर वापस लिखना है तो आप क्या है, उसको देख के वापस लिख सकते हैं. लेकिन रिप्रोड्यूसिबल में क्या है कि मुझे ऐसे प्रिंट करके या पूरा मेमोरी में स्टोर करके नहीं रखना है. आई सिंपली विश टू जनरेट द सेम सीक्वेंस.
Okay.
ओके,
Yes, sir.
तो वो पॉसिबल है
Hmm.
विदाउट स्टोरिंग इनटू द
Memory.
फिजिकल मैनर्स.
Hmm.
ओके, यू कैन.
Yes.
और मेमोरी में सारा आपको स्टोर किए बिना आप उसको रिप्रोड्यूस कर सकते हैं. तो वो हम आएगा अभी. जैसे मैं आपको लीनियर कॉन्ग्रुएंशियल मेथड्स में आपको बताऊंगा. तो
Hmm.
पहले तो हम शूडो रैंडम नंबर जनरेट करेंगे, और शूडो रैंडम नंबर जनरेट करने के बाद देर आर डिफरेंट मेथड. शूडो रैंडम नंबर जनरेशन मेथड इज अ डिफरेंट. और उसके बाद फिर आया एक मेथड कि भाई मैं शूडो की जगह पे इफ आई यूज द लीनियर कॉन्ग्रुएंशियल मेथड, तो शूडो रैंडम नंबर्स में क्या हो रहा है, मेरा इंप्रूवमेंट हो रहा है कि नहीं हो रहा है. ओके, तो वो सारी बातें हम उसमें देखेंगे.
Hmm.
यस, एनी
Yes.
मोर क्वेश्चन,
No,
एनीवन?
sir.
Hello, sir. Fifth point, large period. Can you explain that, please?
लार्ज पीरियड मीन्स एज आई से दैट कि सपोज आपके पास सीक्वेंस आई, आपने पहली बार रैंडम जनरेट किया, यू गोट दी, लेटर से जीरो नहीं लेंगे हम, इट इज ठीक है, रैंडम नंबर ले रहे हैं तो दैट इज नो इश्यू. लेट अस से you get this sequence 1 5 7 9 8. Okay, now after, again when you generate the six random numbers, if it will go 1 5 7 9 8, वैसे इसमें ये जाएगा कहाँ तक, 9 तक जाएगा, क्योंकि 10 इसमें नहीं ले रहे. तो ओके, लेट मी टेक 3 नंबर ही लेता हूँ. सपोज आपकी सीक्वेंस आपकी यहाँ पे है 0 1 2 3, और आप जब रैंडम नंबर जनरेट किए, शूडो रैंडम नंबर, तो आपको 1 मिला, 2 मिला, 3 मिला, 1 मिला. ठीक है, लाइकवाइज आपके पास जनरेट होती गई रैंडम नंबर. लेकिन आफ्टर सर्टेन टाइम सेम सीक्वेंस इज रिपीटिंग. ओके, तो व्हाट इज दैट, हाउ मेनी steps I have taken here. So this is the first step, second step, third step, fourth step, likewise. तो सपोज ये 16 स्टेप के बाद ये सीक्वेंस रिपीट हुई, देन पीरियड इज 16. But after what period the same sequence of random number is repeating, so that is said to be a period. And if this is the case, so you can easily say that no, after 16 it is repeating. As I said that यहाँ से शेयर मार्केट में अप जाना शुरू हुआ, तो अब कहाँ से अप वापस मिलेगा, तो भाई 16 पॉइंट जब आएगा तब जाएगा. तो सिमिलरली इफ यू रिमेंबर इन क्वालिटी कंट्रोल, यू कैन डिटेक्ट द स्मॉल शिफ्ट, ऐसे 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 जा रहा है. व्हेन यू विल आइडेंटिफाई द प्रोसेस इज सेड टू बी आउट ऑफ कंट्रोल, तो यहाँ से आप आइडेंटिफाई कर देंगे कि भाई यहाँ से शुरू हुआ है, तो कितने स्टेप्स के बाद यू से दैट द प्रोसेस इज आउट ऑफ कंट्रोल. तो वी से दैट इट इज एवरेज रन लेंथ. कितने नंबर ऑफ पॉइंट्स के बाद, ओके, और आइटम प्रोड्यूस होने के बाद आपका प्रोसेस आउट ऑफ कंट्रोल जाएगा, तो दैट इज सेड टू बी ARL. हम यहाँ पे बात कर रहे हैं कि कितने ऑब्जर्वेशन के बाद सेम ऑब्जर्वेशन रिपीट हो गए, तो दैट इज सेड टू बी ए पीरियड लेंथ. तो अगर वो यूजर्स को पता ना चले, एज आई से दैट कि आप जनरेटर यूज कर रहे हैं, यू आर गिविंग द प्रोग्राम, तो आपको पता है कि कितने पीरियड के बाद सेम सीक्वेंस रिपीट होगी, बट वो आपने बनाया है, आपने मुझे दिया, आई डोंट नो एट व्हाट पीरियड इट इज रिपीटिंग. तो दैट इज हाउ, अगर मुझे पता चल गया, तो मुझे आपकी स्ट्रेटेजी पता चल गई कि भाई इतने बाद हो रहा है, तो आई विल think accordingly. Okay, and that is how we always take that period should be very large. मतलब 10⁻50 पीरियड लिया है, तो उसके बाद ये जितने भी डेटा जनरेट हुए हैं वो क्या होके सेम रिपीट होगी. तो दिस इज अ वेरी बिग नंबर्स. एंड इफ इट इज सेइंग दैट इफ यू विश टू जनरेट द n, सपोज n इक्वल टू आपने 10 लिया, तो पीरियड आपका कितना होना चाहिए,
1000 हो.
10,000. If the period is 1000, then n equal top whatever the 10 numbers you have generated, that 10 numbers will repeat after the 1000 steps. मतलब 1000 रैंडम नंबर जनरेट हो गए ऐसे 10 10 वाले 100 रैंडम नंबर्स, उसके बाद जब 101 वाला रैंडम नंबर्स आपके पास जो सेट आएगा वो कौन सा होगा, पहले जो रिपीट हुआ था वो। ठीक है,
Yes.
ये जिसने क्वेश्चन पूछा उनको मैं बोल रहा हूँ।
Yes, sir. Yes, yes. Thank you.
Any more questions, anyone? So what we have seen today in lecture, we have seen in COSM there are two parts which we are going to discuss. First is the generation of random variables from a specific distribution. So let us say why random number generator is required. So random number generators are mainly useful to generate a stream of random numbers u1, u2, u3. They are IID and follow this specific distributions. And if this distribution you take is a uniform, then this the stream of random numbers is generated from the uniform random number. But why you require this random number generator? Because if you wish to do all the random experiment in a computers, nowadays the peoples are using the Monte Carlo simulation methods, and Monte Carlo methods, the heart of the Monte Carlo method is nothing but the random number generators. So that is how we are always looking for the random number generators. There are so many random number generators are which are given inbuilt, okay, but as a user has to supply the initial seed, and the person or the scientist who is the pioneer for the pseudo random number generator is nothing but Pierre Al Usher, okay, who has given the concept of a random number generators. So he has given the algorithm. If you use this algorithm, it will generate the generic series of the random numbers, and whatever the random number generator is said, it is said to be a generic random number generators, and which require the 5 different notations that you have to supply the information. That is the S for the, it is a finite states, it is a finite set of the states. F is a function from S to S. Mu is nothing but some probability distribution on S. U is a output variable, and G is a function of S to U.
सर हेलो
Hmm.
सर फंक्शन एफ यस टू यस मतलब कैसे आएगा वो नंबर का, अगर हम नंबर का एग्जांपल लेके डिसाइड करें तो?
वो मैं आपको जब वो एग्जांपल हम लेंगे उसमें चलेंगे, लेकिन सपोज S की वैल्यू आपने सपोज 2 लिया और f
यस
ऑफ
सर।
s जो आया उसका रिजल्ट क्या है, आपकी यहाँ पे रेंज है 0 1 2 9। तो इसका मतलब जो f ऑफ s का रिजल्ट आएगा वो भी किसके अंदर, ये सेट के अंदर ही होगा। तो वी से
ओके
दैट f इज ए फंक्शन ऑफ s टू s। गेटिंग माय पॉइंट?
ओके यस
s
थैंक यू।
कोई भी एक नंबर लो, उसमें आप फंक्शन, जैसे आप मॉड्यूलो ले लो,
हम्म
मॉड्यूलो आप लेते हैं 2x प्लस 3 मॉड्यूलो 5। तो x की वैल्यू क्या है, 0 से आपने यहाँ m मॉड्यूलो 5 दैट इज 0 1 2 3 4, क्योंकि 5 मॉड्यूल लिया है तो उसका आउटपुट क्या, रिमाइंडर क्या होगा, 0 से 4 तक ही आएगा।
यस सर।
तो सपोज आपकी x की वैल्यू लिया है 0, तो 3 मॉड्यूलो 5 व्हाट इज द आंसर, इट इज ए 3। तो 3 कहाँ पे, यहाँ ये। सपोज आपने 2 लिया x की वैल्यू, तो 2 2 जा 4, 4 प्लस 3 7, 7 मॉड्यूलो 5 इज 5 1 जा 5, तो 7 minus 5 is
दो
2, so that
टू
means okay, so that is the f is a such kind of a function. When you take the f of s, the result is also belong to the s. Okay,
थैंक यू सर।
so he has suggested the algorithm that you have to first initialize, and in a initialized status you have to give the initial value of the seed, set the value of t equal to 0, and that whatever the seed you take s0, it should be randomly draw from a distribution mu, that mu is defined on a S. Then the second property, second step, we say that there should be a transition, that once you go note the value of S0, then what is the f of S0? So you can have the S1. Okay, so you have to set the second step like that, st is equal to f of st minus 1. Once you have this st in your hand, you can obtain the output, that is output ut equal to g of st, where g is nothing but function of s to u. So you apply the g of s, whatever the results, it will come to the u. And then set the t equal to t plus 1. That means you generate now another step. So repeat the step 2. So you will get the sequence of a random numbers. It is said to be a stream of a random numbers u1, u2, u3 up to. So when you wish to generate the random numbers, how will you identify the which random number generator is good or bad? So good random number generator satisfy the certain properties. So what are that properties? That properties are, it should pass some statistical test. It has some theoretical support. It should be reproducible. Generator should be fast and efficient. It has a large period. It can help you to generate multiple independent stream. That is how it is a multiple streams. It should be cheap and easy, and it should not produce 0 and 1. So these are the properties we have seen. Any questions, anyone?
No, sir.
No, sir. No, sir.
Okay, so let me take attendance quickly.